All right, guys. Next up, we have the next generation of web exploits from cache poisoning to multi-level fingerprinting. Why complexity itself is the vulnerability with Steven Sprecher.
Hi, everyone. I appreciate that. I also appreciate you coming. I know it's after lunch and we're like ramping down, is that a phrase? And so hopefully we can have some fun here and learn a few things about some complex web system problems. And please feel free to stop me at any point and ask questions. I come from an academic background, so I'm very used to students just either interrupting, whatever. And I actually like it better that way. So if something's confusing, let's stop and clarify, and then let's have some fun. So what I wanted to talk about first is system complexity. Has anybody heard of this OPT or OPT project before? This is internet mapping. It's old images, but essentially it's this visualization of the complexity of the web, basically just IP mapping and connections between network level things. Hopefully you can see from the images here, just in those 7 years, even all the way back in 2010, we're seeing this exponential boom within complexity of just the internet systems at that networking. But if we think about this when we zoom down, up, let's go up in the networking stack. When we think about web developers and their choices, they have so many choices to build a system that does maybe the same thing. You get your choice of framework. You can choose what CDNs you use, if you use load balancers, how you develop your CI/CD pipelines. If you think about each one of these components is adding complexity into the web ecosystem in general. If you're familiar, and I don't know if you are, and we'll talk about it in a second, but getting a web request to you is a miracle of system coordination. And what we're going to talk about is that complexity and how that kind of exposes a new attack surface beyond what's traditional bugs versus no bugs. So given that, clearly this is a little bit outdated. It's a couple months old on the 2025 things, but hopefully what we see here is as this complexity is growing, we're getting more and more CVEs. And if you notice at the top, 90% of those are web-based CVEs. So that things like cross-site scripting, SQL injections, they're just getting worse. And I want to argue that the added system complexity that is continuing to grow, and cough cough, if we think about AI being plugged into everything as well, think about how many more things are getting complex and getting shoveled around places. So it's just kind of going to get worse. Yeah.
Are we lucky, or is that a data problem? Zero, low, right?
This is a data problem. So this was pulled like in April 2025. So incomplete data just in general, but I like it that it still shows the trend up until 2024. Yes. Otherwise, we're having the best year ever. I don't know. Okay, so again, my thesis here, my argument is that this system complexity is an attack surface, and we'll go through a couple bugs that you'll see not a single system is vulnerable, or not a single node in a system is vulnerable, but because you put them together, you now have a vulnerability. And specifically, we're going to talk about, like I just said, yeah, there we go. And they're really, really hard to identify if you think about it. You can't scan one technology and get a vulnerability report. You need context-aware systems to be able to figure out, well, you have Cloudflare, Varnish, Nginx to deliver your web content. How do they interact with each other? And there's not really tools to be able to do this for us as defenders. And who's going to fix this also? It's not a problem with any one of these servers. So we'll get into a little bit of discrepancy between understandings between technologies, but who's going to take responsibility and make some sort of change? Well, unfortunately, enterprise or businesses that use these systems don't have a solution and can't blame anybody and tell them to fix it. So we'll see what we can explore and what kind of tools we can poke at things and try and help. And we're going to talk about web specifically because it's easy to talk about complex systems on the web. As we saw, the web is very complex. And specifically, we'll talk about desync attacks, cache attacks, and a whole bunch of other cool things. Was anybody at Black Hat last month? If you were, there's this guy named James Kettle from Portswigger, the people who make Burp Suite. He gave a talk on how HTTP1 must die. He's done this 5-10 year saga on desync attacks on the web. So we'll talk a little bit about that, break them down as well so that we can, they're confusing. So let's see if we can make sense of it. And then I have to talk a little bit about academic expansion just because we'll see that we can actually leverage academia a little bit in some of these situations to actually help us defend things. And then I have to talk about AI just a little bit, because duh. But also, if you've noticed that a lot of hackers are using AI now to get better capabilities, do some scripting things, and I get really worried about where this is going to go, of basically speeding up the attackers to pull from, let's say, academia or cutting edge research where us defenders are lacking. And so we'll kind of so yeah, I guess I haven't even introduced myself, so that I'll do that right next. So we'll talk about who I am for half a second. We'll do a quick web refresher just so we have a shared context and language to talk about these systems. And then we'll go through a bunch of different attacks basically and explain them, make them make sense. I'll show some examples from our bug bounties and some academia from where we got some CVEs and some cool shit. Excuse me. And yeah, we'll talk about all of these: request smuggling, expect header, T-Rex is a tool we built to help find some of this stuff, etc. And how this implication, what tools you can use right now to actually start poking at some of this, and what do we do next? And then obviously. So yeah, I said all that and I didn't tell you who I am. I apologize. My goal was to hook you a little bit before I tell you. I've been doing cyber security stuff since about 2015. I kind of started by working at NSA for a year. It was an internship during college, don't hate me. And I got to do a lot of cool stuff and see some cool things, and it kind of got me started on cyber. And then from then, I've been doing research and teaching in academia for quite some time. I did my undergrad and master's at the University of Michigan, and I ran the big security course there for a couple years. And then I came here to Boston, not here, this Connecticut, but I came to Boston to do my PhD, which I just graduated in April. But we do some cool system security stuff. But I've done the gambit: malware research, ransomware research, network measurement was very heavy at Michigan, censorship, web, do a lot of system security now, web stuff. That's what we're going to talk about today. I'm a new time founder at a company, so that's my job right now. I won't talk about that because this isn't a sales pitch or anything. We're just talking to have cool stuff. Yeah. See, if I had known we had polarized glasses, that would have been so cool. We're technically in stealth also, so I won't even tell you the name of the company, but yeah. And then I've seen this sometimes, but like statements are my own, not any of these institutions. And then this is my dog. I'm pretty obsessed with my dog. She'll make an appearance a little later to help illustrate some things on the web. She's an 80-pound Great Pyrenees, and she's the best dog ever. Okay. Happy to show you the 30,000 photos I have of this dog after the talk. Okay, any questions before we get in? Awesome. Sorry if this is a little bit like an academic lecture. That's my training. So I do love to have this be interactive with you. All right, so very basic web stuff, right? You have a user, they want to see a dog, they want to post a picture about their dog. Yeah, I'm going to talk about dogs. And so they're going to send some sort of request to this amorphous internet blob, say, give me dogs. And this internet blob is going to say, here are your dogs. Can we agree that's kind of the general flow of the internet if we super simplify things? What really happens, right? Let's say you're probably more so talking to something like a CDN, where you're asking in the front end that the user is interfacing with Cloudflare, Akamai, Fastly, Google, whatever you want. And they're either serving you some sort of cached version of this or whatever, but you as a user have no idea what's going on beyond the CDN. This is just this black box that gets you dog pictures. Cool. So let's unmask a little bit of that complexity, because that's where we're going to talk about a lot of these complex systems issues. So in reality, it's not just one user, obviously, right? You have two users talking to CDN at the same time. It's only two, it's never more. And what really happens is the CDN has to go get these dogs from somewhere. And we'll call this the origin server. So the CDN says, hey, if I don't have a dog in my cache, I need to go ask the origin server, where's this dog? Right? And for performance reasons, all CDNs actually use a shared upstream connection between the CDN and the origin server, which means all of these requests coming in the CDN go and share one request going to this origin. So if you and I both request the same dog or some request from dogs.com, that origin server, we're going to share this same connection for our requests and our responses in this upstream. So we're already starting to get a little complicated, and I'm not even going to mention or bring it up today, but it's never just two. It's like 5 pieces here in the middle. It's a CDN, then you have a load balancer, then you have some cache layer, then you have something else, and it throws it over to an origin server. Oh, by the way, 5 different origin servers. It's a complicated mess. But even with this, we can actually dig into some of these complex issues and talk about some of these. But what ends up happening here, just to demonstrate how this queuing and process works, request 1 comes in and gets queued up. Request 2 comes in, gets queued up, and then the origin reads them off of this one shared connection, basically bites off the line, sees one request, responds one request. Sees the next one, responds, and then the CDN in order spits them back out from the response queue. That's what this part's called. Okay, cool. I kind of talked fast and through that all very quickly. This makes sense because once we have this, we can dig into some cool packs using this. This thing here? No, actually. So if we have 3 users trying to hit the same origin server at least, a CDN for their performance is going to actually only open up one TLS connection to the origin server, TCP in the SAD case, and send everything over that one. And then the CDN has their logic to be able to make sure the right person gets the right request. So yeah, complicated as hell, right?
Then if a 4th person shows up, asking for picture, the second picture, 2-person.
We might serve that out of cache or let's say maybe it's a post request, so it has to work. So we're going to get into all this. I love this. You guys are ready to go. Excellent. So let's talk about our first attack. It's called HTTP request smuggling. It's kind of this category of attack. What ends up happening is an attacker crafts some sort of request, and it's one request, but it looks like 2, and there's something in there that causes some confusion between the systems in this node. The CDN for this specific request will see one request, and we'll handle it as one through this whole system. But what ends up happening is the origin server sees these bytes and says, oh, I'm confused here. These are actually 2 requests. So now it's going to produce 2 responses to one incoming request, and we have all sorts of fun we can get up to. Cool. Oh, I went back. No, I went forward. Okay. So we're talking abstract, and then I'll show you like some actual bugs that cause this discrepancy with different server types in this chain, and then I'll release you to go attack people. Please don't. So what happens here? Let's just run through the same sequence. So the attacker sends this one request. It's bytes on the line now. The origin server will eat this, split it because it sees 2 requests, and respond to both requests on the queue. So we had 1 person on the input, and now we have 2 responses sitting there. As a CDN, they're not going to close this connection because everybody's trying to get pictures of dogs. So we're going to leave this open for performance reasons. And what happens is your attacker gets response for that first part, and the second part just sits here in the response queue. And what we have now is response queue poisoning. So the second somebody else comes on and says, hey, I want my dog photos. Let me know if it's getting too much. I'll not change it. And we're going to send my request to get a different dog. So it has to go all the way upstream. It's going to send here. Origin's going to produce a response, but the CDN responds with the smuggled request instead. We kind of see how this could be really, 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 really bad in certain circumstances. Let's say there's maybe a session key involved that gets sent back, or rather, this is a response here that's sitting in a queue. So the third person that comes along gets that response. And if there was a session cookie or a token or something bad there, that third person, probably the attacker, is going to now grab that. And here's the crazy part. The CDN's not at fault for this. They're processing things how they do. They're just forwarding a request. The origin server, also not at fault because this is this weird amorphous part in the specification where they can do something or nothing and it's fine. So who fixes this? Well, sometimes you yell hard enough and the origin server will say, oh, okay, we'll fix that. Or the CDN will maybe try and do some sort of firewalling to make sure it doesn't happen. But it's a complex system. You update the origin server, new bugs. Obviously not bugs on the origin server, because that would defeat this whole talk, but bugs in the system where they now communicate a little different. Okay, so let's just talk straight up real. This is from James Kettle's talk last month. He published a white paper on this. And basically, as you see it on the left there, that top request is in blue. And it's this post request. So it's going to go through the CDN and get to the origin server. And what happens here is the origin server and the CDN disagree what to do with this expect. the CDN says, that's cool. It's all one request. I see a content length of 64. I'm just going to put it in the pipe. And then the origin server says, oh, I'm expecting something. That's awesome. I'm done reading this request. And so it'll then pull the next number of bytes off the line, see a second request, and respond. And Kettle did things like this, especially with the expect header and a few other little tiny tweaks or bugs or different headers. And I think he was talking in his white paper a couple $100,000 worth of bugs just on stuff like this alone. Because again, who's going to fix this? But it's also a huge problem. One of the cool parts is I think he got this off by one problem on, what was it, Netlify, something like that, and basically was able to receive requests from thousands of users with tons of sensitive data just continuously. So I don't know. Hopefully, I've impressed that it's a little scary of what can happen. And this was in last month, and that's awesome. And here's my pitch for academia. Me and Bruce here, we found this 5 years ago and published a paper about it. Boom, right here in one of our tables, we found the expect header. This is a problem. And James Kettle didn't write about it until 22 and said, I didn't find anything about it. And now it's like the big thing in the white paper in this talk. So not to be, this sounds white. It sounds like, oh, I found it first. And I don't mean for that. In fact, I made AI make me a meme about that. That's not what I mean. I mean, I think we should maybe look towards academia for some situations to where we can pull and get better as defenders. And that's where this AI argument comes in, is I'm kind of scared for AI to be able to go do this. They could read our paper, they could find this bug, and we could have attackers that are 5 years ahead of defenders for certain things. Academia is also way behind on some other stuff. I'm not a huge fan of either, so don't worry. But specifically, I wanted to talk just a little bit about that paper and that table there. Actually, there's 3 tables. And they refer to experiments that we ran, basically systematically looking at every single part of an HTTP request, saying what can cause these discrepancies. And that's where this incentives are disaligned or differently aligned between academia and industry. I can afford in academia to go spend 4 months building a systematic search tool that either gives us nothing or something. But in industry, I hear the incentives don't align with doing 2 quarters worth of work that does no bugs. So I think this is where we can maybe play with each other and make things better. But yeah, here's a HTTP request. I'm going to post this picture of my dog. Yes, she's still adorable. And we have a request line there that says, what method am I doing? It's the post method to the /dogs endpoint, and I'm going to use HTTP1. Then you have a header section where you specify different key value pairs. Here I'm just saying I'm going to send this to example.com, and I'm including 100 bytes worth of content in this body. And then you have the 100 bytes worth of content. That picture is not 100 bytes. It is huge because it is very detailed. So what we did actually is on each part of these massive fuzzing experiments to see what little bugs can we find that cause discrepancies between certain. And this is what we found. We found different things where you mangle the methods up here in the request line, messing with return characters and things like that's always a big win. Different embedded request lines within request lines. These are things where some servers will either do something different with it or respond or decide things. We did this for every single part. So headers here, that was the expect header. Lots of things with different transfer encodings. Are we kind of familiar with transfer encoding and content length? These are ways for you to specify how much data and how you're going to send it to an HTTP fellow communicator. So if I say I'm going to send you 100 bytes, that's a content length. I could also say I'm going to transfer it to you in chunks. I'm going to send you a chunk at a time with a specific format where I'm going to say, here's 5 bytes, send you the 5 bytes, and then send you the next chunk after or whatever. So obviously messing with that can change where these boundaries are for these requests if you have differing opinions. And then we even mess with the body of a message, and we found some discrepancies there, often around these terminal characters as well, or changing chunk size and stuff like that. But we basically have tooling that you can go and play with immediately and kind of replicate some of this or pull some of these things and mess with. Okay, but the key thing here is we've caused discrepancies. And specifically with the smuggling instance, I show you a discrepancy that one said something and the other says, I see 2 things, and now we have a problem. It's not just that. we can actually force this to happen with something in the middle that does a transformation that then causes discrepancy. So this is a real bug that we had a CVE here for HA proxy in 2023. And we can talk about it because it's published, so that's good, awesome. And this is the literal attack payload that we had. Essentially, it's an options here, and the confusion comes where we omit the name. These are key value pairs for a header, so we just don't tell you what the header is. And HA proxy says, cool, man, I'm going to clean this up for you because I know you made a mistake. And it just drops both headers, the content length and the other thing. So obviously a pretty big bug, and that this was definitely a problem of their parsing, basically. They were being nice though, which I appreciate. But now you have an options here with no content length, and options doesn't need body. So you're going to have other servers, and the origin servers say, cool, I got an options, that's awesome, I'm done. Now I see a second request. So the attacker didn't even necessarily send something itself that just went through. They sent something that's going to now get transformed into something that's misunderstood, which is terrifying. So just to link all of the language together, that's the same format of 1 and 2, and that happens, right? So cool. Makes sense so far? I want to just take 1 second to pause. Awesome. They are complex systems issues, so I want to make sure we understand the system, and then we can. So in this situation, this is where we left off with response queue poisoning, right? Where we talked about this second benign user asked for something and got a response to a requested index. So what happens if they were asking for something secure, like we were talking about, or having some sort of cookie involved or something? Well, that's left on the response queue. So what does hacker have to do? They come, they send any good old request, and now they're served the next request on the response queue. They now have your secret. I can now session hijack. I can do all these terrible. Awesome. Doom and gloom enough? Okay, cool. The next thing I just wanted to touch on as well is fingerprinting, firewall bypass, 8 minutes left, and access control bypass. So if you think about this number 2, that this WAF sees one request, right? So if we're doing filtering, let's say on the request line or headers or something, number 2 doesn't get looked at that way. It gets looked at like it's a body, but the origin server is going to process it like it's a request. So now if there's something that you need to sneak in, let's say a SQL injection in a header field that you have a firewall rule deployed for to look for a signature, well, you're not looking down here. So now we just fully bypassed your $1 million firewall that you've installed in your enterprise, and your origin server now sees a second request, boom, SQL injection. What is it, Johnny drop tables or something like that, and things happen. Well, yeah, what is it? Bobby. Either showing my age or it's tired. But yeah, so it can go all of these different places. The blast bypass, access control stuff, that's kind of fun, scary things you can kind of throw at. And this is just because of this complex system. It's not necessarily a problem here or here. It's just they kind of disagree with what should happen with this thing. Okay. And so we're not just needing to smuggle, we can do other things. We don't need to smuggle a new request in, but let's use some of these misunderstandings and cause some other problems. So here's just a normal request. It's a get for homepage with a host header. CDN says, cool, that's a request for the homepage, totally valid. The origin says, this looks great, here's the homepage, that sounds great. Actually, we got a couple $1,000s for submitting bugs, and this is the exact thing. It's just this header. It just has to be the right setup, and we test safely so we don't take things down. But essentially, CDN says, that's cool. That's a request for home. I'm going to cache this response as the home page. The origin server says, I don't have whatever this type 1, 2 through 9 is. So I'm going to give you 412. And guess what? Cache server caches the 412. So now we have a single request denial of service on your entire homepage. So quite literally what ends up happening, we're talking about caches, so I'm just going to assume a little bit of knowledge about how caches kind of work. And let's see that the home page is uncached so far. So the attacker is going to slip right in before it's cached, send this problem. Origin server responds to the 412. We cache that 412, and then things get served from the cache. User comes in, I'd like my home page, please. And they also get this error. And we've taken down a full website. One request to each cache edge. Okay. I'm scared too. That's good. And so it is that simple, like that exact bug. here's some of the other ones that we got from bug bounties on HackerOne. If none match star, so it doesn't necessarily mean the value resulted on this one company as a cache 304. Transfer encoding looks all good, just added an extra dash, or your server could not deal with that. And so it said 400, I can't do anything, but CDN cached this. I'm not saying what CDN, but I think not too important. Are we familiar with XHTTP method override? It's like meant to say like, please override the method as this, not that. And so when you say head, it says, oh, if I respect this, I'll treat this request as a head request and only respond with headers, no body. And so when you do this with a GET request for a home page, guess what? You might get a response back with an empty home page, and it's all good. And so that gets cached as well. We've now gotten rid of clear content. And I think that one I can talk about. That was on Mozilla, and it was only on a static file, so it wasn't like the full home page. But if you think of static files like also JavaScript files that make your site work, or image assets and things like that, oh look, they're now empty. So kind of, I would argue, breaks your site as well. Yeah, and essentially it lasts for the whole cache duration. Fixing this is so not easy. You have to flush your cache, and you have to make sure either you write a rule so the attacker doesn't put that back in the cache right away. And what we would end up doing, at least to demonstrate, we wouldn't actually send this, but say, hey, here are your 5 cache edge nodes. This is public information. I know this. And here's your cache duration. I'm just going to send a couple requests right around when I know the thing expires, and I'm going to try and get in that cache. And now everything behind that cache doesn't have access anymore. So I guess that argument actually escalated one of our bugs from like, I think 10x the payout from the bug or something, once they understood, oh, this is actually very easy to pull off. And cool. Bug bounties, real world stuff. I think we're doing good. I had this in the title, so I'd be remiss if we don't talk about multi-layer fingerprinting. Just to set the tone again, if you remember, all you as the client see is the CDN. You actually don't get to see this upstream. You don't see the technologies that are back there. You just think Steve.com is cloud. You don't know what's going on behind it. So if we did know, then we could even apply more of these issues, because now we know, oh, we have Cloudflare, we have Varnish, we have Squid. I know that there's differences here, so I can send some specific requests. And you can do it smartly, not just spray and play. So I just wanted to talk about the method that we did for this paper, because I thought it was cool. This is the setup where the client is sending a request and it's going through Cloudflare, Squid for, I think, load balancing, and then Tomcat's responding with the actual content. And from this perspective, the client knows nothing. It doesn't know what's upstream. So what we do is we find a request that causes an error on all servers. So that means we know that the first node is going to cause an error. And we'll send that along, and we'll check that error page. Oftentimes, error pages will tell you what it is. It's a Cloudflare error. It's a this server type error. If you have enough of those, you can actually cluster and decide error pages that look like this or this technology, this and this. And guess what? In academia, they let us do massive, crazy clustering studies and grab like millions of web pages and stuff like that. So we did that. So you get a request, you get an error from Cloudflare. I now know that first node is Cloudflare. So then I find a request that Cloudflare we know is okay with, but everything else causes an error, and we rinse and repeat. That kind of makes sense. So now we know it's going to get through Cloudflare just fine, but now we're going to get an error page from the next node. Cool, that's Squid. We do it again, and then we know the last one's Tomcat. Now we have the actual technology stack. And even for normal attacks, now you know something else, and maybe there's a bug on the specific version of Tomcat that's being used that you want to take advantage. And so now you know, versus having to use Shodan and Census and all of these scanning tools to try and figure out what's going on. And yeah, any questions about this? Also happy to talk. And a lot of these tools are open source from our academic days. So like the only thing you might be lacking is data, and I can send us academics, by the way, are like so giddy if you want to talk to us about anything we've ever done. So I can put you in touch with the first author here, and he'll like explode and be like, yes, here's all the data, here's code, let me help you do this. Like, so that stands true for any academic thing you read pretty much across the board. You send an email to a grad student about their work, and that's like the best month of their life, and you're going to get a lot of feedback. And they will help you do anything, and they're cheap because you know. Sounds good. Okay. are we good? We kind of see how some of these complex systems lead into some problems. The system itself is maybe fine. These nodes don't have bugs, but because we put them together in a certain order and they kind of disagree on stuff, we can cause attacks. So I'll argue that this is kind of a different attack surface than what we traditionally look at as security practitioners. Okay, so what is it? Yeah, question.
Not a question, but more of a statement.
I love it.
I've seen instances where even like good setups, like lead information, but this other way.
Exactly.
So not just
Yeah.
errors.
Somebody leaves a server header in or something, and now you say, "Oh, it's Tomcat." Cool, I didn't know that. So you can pull all of this stuff together. Exactly. And the dangerous part is, well, now you know it's there. It actually doesn't matter where it is if you know the front and back, and you know they disagree on something. As long as the middles don't affect it in any way, you can still take advantage. So, yeah, very, very interesting. Hard bugs to kind of hard. I keep saying bugs. It's not a hard surface to get your head around and to do. And let's talk implications real fast. I think, how are we doing on this? I'll wrap up quick. Sound good?
Yeah.
10? Oh, that's more time to go. We can still hang out. Okay, cool. So it's not just web, and this is the maybe let's explode the fear just a little bit. I don't like the fear monger, but like I'm kind of scared about this stuff, so now you get to be scared. And we talked about web and how this is a problem. Some of the recent academic work is looking at this and finding very similar problems within SMTP, so the email protocol that everybody uses, right? A couple papers here, posters in academia that are exploring kind of how we did with the headers and things like that. Anything that's parsing data, right? Zip parsers have this problem when you have, let's say, 2 zip parsers, or you zip something here and unzip it with gzip here and 7-zip here. There's have slight different implementation issues, and so there's been some academic work exploring some of these problems. You can go all the way to DNS because there's a bunch of systems involved here. Anytime you think of, I have something that needs to communicate and coordinate with a bunch of different systems, AI, when you chug it into everything, now you have this new attack surface that we as defenders don't have visibility on, don't know what to do about, and we need better tooling to be able to do this essentially. Oh yeah, another DNS paper. Oh, scary. Oh. Not cool. Very scary. And then just to drive home the point about how AI is assisting hackers now, and what I'm scared about it, that's going to start eventually helping get them ahead of the curve. So pull from 5 years ago our research and start doing things that the attackers don't have signatures for, don't understand what's going on. Obviously, there's everybody and their sister has written an article about AI and AI hackers and assisted, and you're getting right now it's a lot of automation assistance or kind of more simple tasks, that repetitive tasks for AI. It definitely will be moving in. Hey, let's do some vulnerability research for me. I need this, and it's going to scare me a little bit. And on that note, actually, one of our friends just started a company. They raised about $9 million to do agentic threat hunting. So in your enterprise, plug in this box and we'll do threat hunting 24/7 as an agent in your network. And that's awesome. I think it's super cool. I'm also really terrified because if we can start learning or pulling in new techniques and things like that, now you're getting somebody more advanced than we have the capability to defend against or really. Yeah. Anybody else like kind of scared about AI just a little bit? At least in the future. Right now, it's so dumb. I spent like 3 hours the other night debugging in a loop a certificate issue with Caddy or something. And it's like, do this. Cool, I did it. Here's the error. Oh, actually, do this. It's just undoing itself constantly. It's got a way to go, but it'll probably get there, which is not fun. Okay, so what tools can you use to get maybe some insight right now in open source stuff? How many of you use Burp Sugar? Awesome. So there's some built-in extensions written by James Peddle to help with some of these things like HTTP request smuggling, RAM miner to find things so you can test safely. There's this thing I skipped over because we didn't have time. To test safely, you need something called a cache buster to make sure you're not actually overwriting the cache for like a home page. You're overwriting a new entry so you can see behavior. So RAM miner is really helpful for stuff like that. And will warn you, it's a fixed small subset of these bugs that it looks for actively. It's not oh, all the things in our paper they get to look for. It's here are the things that they found some success with, and so you're going to scan for just these. Actually, this request smuggler was built in conjunction. This is DefParam, if anybody's heard of DefParam. I think this is the one tool on GitHub by DefParam, but it helps you test for HTTP smuggling a little bit. Again, the same thing, a fixed number of things. You can see exactly maybe X override or HTTP method override. H2C, so we were talking HTTP1. I think it's just easier to depict HTTP1. Some of these problems exist in HTTP2. But some kind of go away. So some of these desync problems disappear, but not necessarily the confusion in the system, disagreement on different things. So we still have that. And for research tooling, if you want to poke at our research tooling, those three tables I showed you came from this paper, T-Rex, that was drawn by Beiruz's daughter, and we're an academic. That's the logo forever. I love it. And it's a tool you can run this fuzzer to find these new things, and it'll continually do this. We basically specify a grammar and just say go. And we did that for a couple other things. Frameshifter does this for HTTP2, not just HTTP1. And then we messed around with trying guided fuzzing. Is anybody familiar with guided fuzzing? Just feedback of like, I say something, a seg fault happened. Cool, let's do more of that. But we do that for HTTP requests. And honestly, just use Frameshifter too. The guided part is not as effective. That's what something we get to do in academia, right? We say, oh, this would be cool. Oh, it sucks. All right, cool. Moving on. Okay, awesome. So those are the tools that I know of available to even start poking at the surface. But again, it's scary to me. So what do we do next? I think because seems to me like the next generation or new attack surface, as things are still getting more and more complex, we're having more and more issues that arise and less visibility. We kind of need a new approach to tools or thinking about these problems that are aware of this complexity, kind of aware of your whole system. What's the buzzword? Context aware for like, oh, GitHub Copilot's context aware for your whole project. Well, okay, we kind of need that for entire infrastructure because you have this and this and this and this plugged in. Oh, your configuration changed on layer 3. Well, that causes this whole different thing. We need to know how this is going to affect things. And for detection and prevention, and the data's out there, right? Everybody's logging every request that's going in and coming out. We need to just be able to ingest this and say, oh, here's how this server behaves on these kind of requests. And the small part of academia that we could probably pull from is, since we have the incentives to be able to do systematic explorations, pull some of those techniques and be able to look systematically, complex reasoning, to find all instances, not just the one that we kind of heard about and had a cool thing about and got some and measurements. I'm your guy, by the way. Come talk to me about big measurements and data stuff. I'll help out with that. Honestly, does anybody know what the heck's happening here? This has been happening to me for 3 weeks. It's just like, hey, insert your contact. And then I click it and it just goes away. Anyway, cool. I'm hacked by the NSA. That's fine. So this is what we talked about. I pretty much have a non-existent digital footprint beyond my website and LinkedIn. Really intentionally? I don't know. So if you need to get in touch with me, my email's on there. LinkedIn is fine too. And also always happy to talk. I'm also one of those nerds who, if you're vaguely interested in what I talk about, I will talk about it with you for 3 years until you kick me out. So